Okay, sir. Thank you, sir. Thank you. Thank you once again.
Dear participants, please fill up the feedback form, which will be shared in your WhatsApp. So kindly fill up the feedback form to the predefined deadline. Okay. After that, your link will be expired. So our next presentation based on IoT communication protocol by Professor Atul Negi from University of Hyderabad. Professor Atul Negi sir is basically from School of Computer and Information Science, University of Hyderabad. He holds the PhD and MSc for UH, University of Hyderabad and IIC Bangalore. He is the director of Prestige Institute of Engineering and Science. He was the chairman of IEEE Hyderabad section, investigator in funded project from ISRO, Ministry of Communication and IT, scientific officer for DRDO project, comrades at IISc. He has more than 150 publications in peer-reviewed conference and journal. Professor Negi has been selected for Outstanding Volunteer Award by IEEE Region 10 in recognition of Professor Negi outstanding contribution and service to IEEE Hyderabad section and IEEE Region 10. Now I would like to invite you, Professor Atul Negi sir, to deliver his lecture. Sir, please come forward. Sir. Sir, please unmute. Sir.
I'm
Yes,
I'm
yes.
audible.
Yes, you are audible, sir. Good morning, sir.
Yeah, fine.
Fine.
Okay. So I think so. We are a bit early as per the scheduled time. So is it
Yes,
okay
sir.
for us to
Yes, yes.
start?
It is okay, sir. No problem, sir.
All
It is
right,
okay.
all right, fine. So
Thank you, sir.
it's uh, thanks to the host for giving me this opportunity to speak. I am interested in many things. For example, IoT security, and things like that. Today, I'm just speaking on, say, a very basic issue, which is the protocols aspect. And I am not making any assumption about the background of people and whether or not they know protocol or something like that. So that's the reason if this is looking very, very basic, I'm sorry for that. But I like to see that, my audience is all on the same page. So I'll switch over to my presentation.
Yes, sir.
Okay, sorry, this is not the slide I wanted to start with.
Okay, sir. No issues.
But that is a very important slide which I need to be speaking about. Okay. Yeah. So as has been introduced, I work at the University of Hyderabad. This is a central university, and the name of the department is called as School of Computer and Information Sciences. This is my email ID, and you can see that. So I am giving more like of an introduction to the IoT protocols, and of course these are protocols are very basic things, and you can build up everything a lot on the protocols, and of course those protocols will be leading to the smart cities and things like that as well. So if we start right at the beginning, so we'll try to first understand that what is a protocol. And of course, as the smart city is based upon what is there in the internet, we need to have a good understanding of that. See, the internet infrastructure, we are taking it for granted, but however, it is good that we understand that what it is there. All right. So as you all know that we are having so many connected devices. Okay, so in the internet we call the hosts as the end systems. Okay, so all the devices, IoT devices, etc., which we are having, they are all the hosts, or in the internet terminology, they are end systems. Okay, that is end systems, and they are running the network applications, and they are at the internet edge. Okay, why is it that they're called as being at the internet edge? Is because they do not take part in routing. Okay, now I can understand some of you who are doing research in MANET, VANET, etc. You might say or object to that it is possible that those MANETs and VANETs, they do their own routing and also, but we are just talking here about the generic view of the internet. So now here what we are having is that all sorts of edge devices are connected, and then they are all connected to the internet, and in the interior of the internet, it is built up out of these routers, which is also called as the packet switches. Okay, packet switch, because basically it takes gets a packet, and then it has to find out that where it should send that. And then there are other switches also, which are actually the switches which look at the packets, incoming packets, and see that which along which line those things has to be sent out to. Okay, and of course, this nothing will work unless you have the communication links. The communication links are the physical connectivity links, by which I mean that you must be having some optical fiber or some kind of a copper cable, or it could be a wireless link, which is either through radio or through satellite. So like this, the communication links would be there, and the important parameters of these communication links is that what is their transmission rate, or the bandwidth rather, that is how many bits per second can be communicated across those communication links. So this is the basic aspects of the internet. And when you put a large collection of all of these things, so then you have the networks, that is a collection of the devices and the routers, etc. And then the links are whether they're managed by an organization, single organization, or by multiple organizations, and they have to then be cooperating with each other. So like this, it is, you can see that it is a fairly complex kind of arrangement, the modern internet. So we can see that how the internet connected devices are there. So why I'm talking about all of these things is that it is related to the concepts in the smart city, because smart city is made up of smart homes, and many of these things are all already there in our home. Okay, so like security camera, internet, refrigerator. Um you might be asking, like, what is there with respect to an internet refrigerator? So it is that the internet refrigerator may be a smart refrigerator, wherein it is looking at the objects which have been placed into the into the refrigerator. Of course, you are scanning the barcodes which is there on those items, and then you are placing it into the internet refrigerator, and then it is getting the product information. And say, for example, if it is a perishable item, which is say like milk, so then the internet refrigerator would be knowing that what has been scanned in and what is its expiry date, etc. And then it is going to give you some kind of a warning saying that this milk which you brought on such and such day is going to spoil, better to use it by this time, or the milk has already spoiled, better you throw it out, and things like that. So this is some example of how these things are connected. Other example which is there is that of that you are having the service utilities. So this is one of the major things which is there with the service utilities. That is how much of energy which we are using and at what time we are using, and things like that. Okay, so in addition to these basic utilities and all, you are having so many entertainment devices. You are having communication devices. You have some way to suppose you ran out of your milk, then you can talk to the Amazon Echo, and then that will authenticate your voice and your account, and then it might give you an order for what you would like to get for your house. Okay, so like these things, these are all the internet connected devices. I have not I have left out all these gaming devices and things like that. You can have a bed or mattress also, which is having sensors, and that sensors would be able to say that whether you had a comfortable sleep or not, and so that way indirectly monitoring your health and things like that. For health, you are having these pacemakers and monitor devices and Fitbit kind of devices, wherein the sensors are interfacing and they're finding out whether your rate of your heart rate and other parameters, vital parameters, are within normal range or not. Okay, like this, then there are so many which are related to transportation. So there are of course so many devices which are there. Okay, so these other things that homes would be like, say, some toasters and which are web enabled and all that. So there are so many other devices. Okay, but what is behind all of this? So behind all of these things is that you have a protocol. Okay, so then what is a protocol? Okay, so for example, let us say that we are having the human protocols. So somebody asks, what is the time? Yeah, or I have a question, or some that is, suppose just say for example that I have come in to speak at a webinar. So as per the protocol, an introduction is given that this is such and such, and he's from such and such affiliation organization, and he is going to be speaking on this title. Okay, so that's a protocol of introducing a speaker into a program. Okay, so like this, there are human protocols. All right. So um, basically, what we mean by protocol is that there is a specific rule for messages. All right, and there are some actions which are taken when the message is received, or there are other actions which are possible when messages are received. Okay. So or suppose there is an event which has taken place. Okay, how do we get to know some event? Because the sensors or those things which are connected to the communication devices will let the process know that such and such activity or such and such event has taken place, and then that will trigger something in the protocol for some kind of activity. Okay, so like this, we have these protocols. Now, network protocols are that where we are having the devices which are being connected instead of the human beings, but then you are having all the very strict rules which are there for the messages and the specific actions, and you are having state diagrams which are there, which are monitoring the state in the protocol. Okay, and then the network protocols, of course, they are responsible for all the communication activity in the internet, which is and it is all governed by the protocol. So finally, we can say that protocols define the format, order of messages sent and received amongst the network entities, and the actions which are taken on the message transmission or receipt. Okay, so this is the basic idea of the protocols. So to understand more with respect to protocol, we also need to look at what is the sequence of the messages which are being exchanged. So we can draw a comparison between the human protocols and the computer network protocols. Okay, so one person is seeing another person, he says hi, or she says hi, and that person responds with a hi, and then that person responds with what they want. Say they want to know the time, and the person knows that okay, he's got a watch or a smartphone or something where he can communicate the time, and then he gives the time. Okay, and then of course there are so many other human protocols, and the computer related things we are having. This is at a transport layer. So you have that one process is communicating to another process which is running on two different hosts. So then there is a TCP connection which is set up, and as you know, TCP connection meaning transport control protocol. So this is the TCP connection request is received first, then a response is given to that, all right, and then the actual transfer, etc., takes place. Okay, so that is how the transportation of data and all can be connected through the TCP protocol. So all the protocols have layers, and you have reference models. Okay, so networks, as I explained earlier, are very complex, and there are so many pieces of the network which is there. So we have some hosts, we have some routers, then we have links of the various media, and then there are applications, and there are protocols, and then there is related hardware and software. All these things are there. So how do we organize the structure of the network? Basically, since the very beginning of the days of the network, internetwork, they have been being organized in what is called as a protocol stack. Okay. Uh, of course, the stacks, etc., are guidelines, because you have multi-protocol kind of applications and all that, and you have cross-protocol design. I mean, cross-layer design and things like that. But basically, we want to follow these reference models and the layered protocols approach, because we want to understand things. For example, suppose every protocol is having objective. Okay, so suppose we are looking at somebody is going to do some air travel. So at the air travel, what do we want to do is that the person moves from a location A to a location B, and of course, usually if we go on some air travel, we will be carrying some baggage or some kind of baggage, at least a cabin baggage, which is having some of our important possessions, and with that we will. So that is what the air travel is aimed to accomplish: the end-to-end transfer of a person and their baggage. How do we do that? Okay, so that is, we do it through this system of some airline travel or something. Okay, so that is, we involve a number of steps, and a number of services are involved. Okay, so as you all know, that it starts with the ticket purchase, and then you try to get a baggage check. Then you find the after check-in and all that, you are going to find the gate where the transfer will take place from the terminal to the aircraft. So that is the loading, and then there will be the aircraft will take off from the runway, and once the airplane takes off from the runway, it will be put onto some kind of a path, which is called as a airplane routing path. Okay, and similarly, once it lands, the airplane lands, the other things will take place in the opposite order. That is, from the airplane routing, you will find out that which runway the aircraft has to land, and where is its gate or halting spot, and then the passengers will be unloaded, and then the baggage will be unloaded, and the passengers will collect their baggage, and using their ticket get to the place where they want. Okay, so like this, but what we see is that everything is a layered service. So each layer will implement a service, and it will do it while its own internal action, and it will be relying upon the services provided by the layer which is below. Okay, so this is layered model of the getting the services is very important, and as you can see that every layer is on top of another layer and all that, so that stacking order can also be seen here. Okay, so and at every layer you have services. All right, so that is say ticketing service, or it is say baggage service, or it is a gate service, it is a runway service, or it's a routing service. So like that, we have the various services. We have the various services which are there. Okay, and as the services are there, so then for each service, how do you run the service? Those things are important. So the question would be that why are we talking about the layering approaches? because when you are having very complex things, so when you are having very complex things, so then we have to design them in such a way that the complexity is limited. All right. So to limit the complexity, we approach we approach to designing and discussing the complex systems within the layers. Okay. So that is the approach for the designing of these interdependent complex systems. So the layering approach is used, and the structure is allowing the identification and the relationship of the system's pieces, and therefore we call it as a layered reference model. The modularization, which is done through these layering approaches, it will ease the maintenance, updating of the systems, and the change in the layer service implementation will not affect the rest of the system because it is internal to a layer. Okay, as long as the interfaces between the layers are remaining the same, the internal implementation can be changed. Okay, so like that, we can work with that. Okay. So now this is about the typical internet protocol stack. So in the internet protocol stack, we have that at the bottommost, which is a physical layer. So the exchange of the packets, etc., will take place to that physical exchange layer. Then there is the link layer. Okay, so in the link layer, what we do is that we are trying to impose a structure on the sequences of the packets, and the addressing structures and data structures and things like that. Those concepts will be set up at the link layer. Okay, that is when we are exchanging packets, we would like to bring some order in the order in which we are exchanging the packets, and which entity is to be addressed, and those kind of things are taken care at the link level address, I mean, at the link level there. On top of that, then you also have the network layer, because if there are multiple entities being connected, so then the linking up between the various entities and the fact that there are different entities, so each entity should have an address. So those kind of things will come in at the network layer. Finally, it will be that we have the main data which has to be exchanged, and that is taken care of. The reliable data exchange is taken care of through the transport layer. And finally, then you have the actual work which is to be done, that is the application. All right, so the application layer is dependent upon all the lower layers to get its work done. And that is the application is also the main reason why we have all these things. Okay, so that's how it goes. Okay, and in our modern networks world, what we have is that you have the application layer which is supporting the network applications. So like we are having hypertext transport protocol, that is the HTTP. Okay, or you have IMAP, or the simple the mail transport protocol. So that is the SMTP. Okay, which is our email. Okay, IMAP is for the web, and those are the kind of things. So then you are having the domain name service, because in the domain name service, the the URL is required to be converted into an IP address. So this translation, etc., is taken care of by the domain name service. Okay, below that, then at the transport layer level, we are looking at the various data transfers which have to take place, and it is always that the applications are dependent upon some processes, and then the ports are required which actually connect to the applications. So for that, then you are having various TCP and UDP ports. Okay, UDP is actually connectionless approach to connecting, and TCP is a connection-based approach to connecting. But the UDP is a messaging protocol. Okay, whereas the TCP is a stream protocol. Okay, so this is the basic difference between the way of connection. Okay, and TCP is requiring a lot of time to set up. So the overheads which are required for TCP are much more than as compared to that for the UDP. Next thing then is that we have these network aspects, that is the routing of datagrams from the source to the destination. So there we are having the IP and the routing protocols. So for example, at network layer, okay, previously we had just 32 bits of addressing, okay, and that used to be sufficient. But then we ran out of the IPv4 addresses. So now it is all the IPv6 addresses. And if you talk about IPv6 addresses, then you're having a 128-bit unique address for each of the end systems. So uh, the communication of the address or the headers, etc., has become quite heavy with these um, uh, IPv6 kind of network layer packets. Then what is very important is that you have the link. Okay, so the link is the data transfer wherein the neighboring network elements can actually transfer certain data. For that we need the protocols and the standards, say Ethernet standard. So Ethernet standard is there for a collision dependent approach. Rather, that is, it's allowing collisions, but fairly statistically it's having a very good properties, and the throughputs, etc., are good and better than some of the other approaches. Okay. So the variations of the Ethernet is the 802.11, which is very popular for Wi-Fi and all that. Okay, and but then there is other kind of things also, say like point-to-point protocols. These are important when we are talking about the links. Okay, so point-to-point protocol being, the most basic or fundamental one. Okay, so that is, if you just connect some few wires, and then you can run the point-to-point protocol, and you can exchange data and things like that. Then lastly, we have the physical layer, and I won't be talking about that at all, because the physical interfaces, etc., are a bit different, and it's not going to be in our purview. So like this, what happens is that every layer is taking the packets, etc., and then the layer on top is encapsulating that packet. Okay, so for example, a message has to be sent across some source to destination. So for that, we have to encapsulate. So it has to make use of the transport layer. So then a transport layer header will be added. And then after that, then the transport layer protocol will be encapsulating the application layer message with the transport layer header. Okay. And so that is a one layer of header. Then another header is added on top of the transport layer header, because it's a network layer header which is requiring that the for the link layer services also to to forward the packets and all that. So then over the network layer header, you are having a the link layer headers, wherein the addressing and other such information is used. Okay, the link layer protocol will encapsulate the network layer datagram with the link layer headers to create a link layer frame. And then the transfers will take place from one device to another, making use of all the physical layer connectivities, and then we're having servers which are all this entire stack of the servers. Okay, so without one, the other cannot exist, and vice versa. And as you have two types of networks. One is the infrastructure based network, another is the infrastructure less network. And the wireless and mobile networks are very convenient, and within a city area. So the infrastructure, wireless mobile infrastructure, depends on the towers, etc., which have been set up, and they in turn have a backbone connectivity. And now in this present world, there are so many more wireless subscribers than the fixed wire subscribers. And there are so many mobile broadband approaches to connect rather than the fixed broadband connections. Okay, so 4G, 5G cellular networks is where we are going, and they embrace the entire internet protocol stack, including the software dependent networks, that is called as SDN. And then there are two important but different challenges, that is the wireless communication, which is over the wireless link, and then there is a mobility based aspect wherein a mobile user could be handed over to another attachment point of attachment into the network. Okay, but unfortunately this mobility and wireless have its own drawbacks and difficulties because of noise. So here we can see that what are the aspects of wireless network and which will be there in all these things. So you have this wired network infrastructure wherein you have you can see this triangular kind of thing which is actually the tower. So this is the tower wherein the links are set up and they connect to the various devices, etc., where those devices will be running some end system kind of applications. So what kind of hosts will be having which are on the wireless? You have laptops, smartphones, IoT devices. They all run applications, and those all these hosts could be stationary, or they could be mobile. Okay, so wireless is not always meaning that there has to be mobility. Okay, and other property will be of the wireless links, wherein you use the connections to the base stations and all that. So various other protocol coordinates will be there for accessing that, and you have having various transmission rates and distances and frequency bands. So, for example, we talked about 4G or 5G. So, in each of these things, the bands and the transmission rates, etc., and the setup, the bundle of protocols which is used is somewhat different. So that is how it is seen. And say for example here I'm giving a figure wherein we are having some very familiar names of the wireless protocols. Okay, so amongst the most famous one is the 802 series. And 802.11 series is actually the use of the concepts of collision-based approach of Ethernet, but which is at the wireless level. And so, therefore, there was a huge evolution between the initial 802.11b and like that, and then now we are having multiple alphabets rather for each of the 802.11 protocols. For example, you are having at a very high frequency end, there is a 802.11ax. Okay, and there the benefit is that one can have very high data transmission rates. And the other aspect to see is that based upon the frequency which is there, there is a distance range. And many places that the distance range is can be very small, maybe within a room, which is through say Bluetooth, or else the distance range could be fairly large. So for example, using a 4G LTE, so it could be in the range of 4 to 5 kilometers, 4 to 15 kilometers. And of course, the others are somewhat in between. And but the 5G 10 Gbps is in the range of 200 meters to a few kilometers. So here we see that what are the elements of a wireless network. The backbone of the wireless network will certainly have a wide network infrastructure. Okay, so that is there in the backbone. But connecting to the edge devices will generally be through the wireless aspect only. So that's why there is still a huge amount of research on the fundamental connectivity of the wireless devices. And there is a concept of a handoff because there could be a mobility. So then if one device moves out from the zone of influence of one network, then it is going to another network, and then there they try to maintain the connectivity. So that is done through what is process which is called a handoff. But we have a basically thing which is called as a base station, which is connecting all the devices into the main network. So now we come to the wireless networks. Now, infrastructure-based wireless networks is not really so difficult, as you have seen in the previous slides, but what is somewhat more challenging is the ad hoc mode. So in ad hoc mode, there is no base station, and the nodes can transmit to each other within their link coverage. And the nodes have to be self-organizing. They need to organize between themselves into some kind of a network, and they need to route the information among themselves. In this slide, I'm trying to show that how do we connect. So we can connect through a single hop. So single hop is that the two entities are directly within the link range, and the host will connect to the base station through either a Wi-Fi or cellular, and which can connect to the larger internet. So that the base station is the one which is actually connected to the larger internet. Okay, so and if there is no infrastructure, then there is no base station, there's no connection to the internet and all that. So but okay, if the physical infrastructure is there, you can survive it despite not having any connectivity. In multiple hops, what will happen is the host will be relaying through several the wireless nodes and connect to the larger internet through a mesh network. Okay, and in these multiple hops also, there is no base station, there is no connection to the larger internet, and you may have to relay each other the information from one wireless node to another wireless node. And we have the mobile ad hoc networks, and then the vehicular ad hoc networks, that is respectively called as MANET and WANET. Okay, lots of research papers, etc. on that. I don't know, I'm not sure, but whether it is okay. Okay, so with that, I have built up the entire background of what is required to have the IoT, okay, and the Internet of Things. So as you can see that things, so it is involved so many things. Okay, so it can involve shoes, it could involve health devices, the passive shelf which we have, it can become a smart shelf. Okay, so suppose you have a smart shelf, and no, it is meant for your keeping your bathing items. Okay, so then the smart shelf will be able to say that whether you are still having any bath soap or it has run out of bath soap, like that. Okay, so these kind of things would be there. Then we also have child monitors which are taking care of that, the the sorry, that is the it's a worldwide network, and the child monitors and things like that are keeping track of that all the people at home, and just like you have child monitors, you have monitors for the elderly. Okay, so like this, all these now you can keep track of the status of people and like that. No, so many devices are there which we need. Now there are so many segments also. So if you see this picture of the Internet of Things on the right hand side, okay, you can see so many icons, and which is connecting that how those things can be connected. Some audio devices, entertainment devices, the beds, and the travel approaches like metro, aircraft, train, and car, and all those kind of things is connected. So like so many things are there, and everything is communicating and connecting. So that is the Internet of Things. So as a lot of people are doing research in the IoT, I can show this slide wherein what is the scope of the IoT technologies and what all it involves. Okay, and this was actually, this figure is from the Sethi and Sarangi authors, and it was published in the Hindavi Journal of the Electrical and Computer Engineering of 2017. And I've given the link, you can find that where it is, if anybody is interested. Let us start from this bottom, that is from the rightmost side, wherein we are talking about applications. So IoT applications, and where you will need the protocols, etc., will be related to energy conservation, to the smart agriculture, health and fitness, smart transport, home automation, things like that. Okay, that is all applications. We know many applications which are there. And then the middleware is there. Okay, so actually middleware is very important because that is going to interface between the core set of services to the applications. Okay, so you can have application specific middleware, you can have some database oriented middleware, you can have event based middleware, some service oriented middleware, and all these kind of things are also there. And wherever I'm talking about middleware, you can even say that some kind of protocol can also be there for that. Okay, if we go into the links and the networking, then you have the communication networking. We can use some wireless sensor networks, the near field communication, RFID and WSN could be the methods to communicate. Okay, WSN standing for wireless sensor network, and RFID standing for the radio frequency identification. So then we have protocols. So the protocols will be for the smart objects, and so where there is a big difference. And why do we need different protocols for IoT? That is because of low power. Okay, so you have a separate set of things which is there, that how the protocols and which were there earlier are now adapted for low power technologies. So say Bluetooth, low, that is a low energy Bluetooth which is there, or low power Wi-Fi which is there, or else there is other protocol well known which is called as a Zigbee. And so you have internet protocol for the smart things or the smart objects. Okay, and they make use of the low power link layer aspects. They are having some adaptation. They are having the routing protocol, and also they said Edison. I mean, sorry, the application protocols which are there for that. Okay. So now at the leftmost extreme, we have all the sensors, various types of sensors. So they're all like, like our sensory organs. We perceive the world through the sensors. So you can have medical type of sensors, environmental sensors, chemical biosensors, infrared sensors, RFID, neural sensors, etc. Like that we can have. And then there are so many other kind of things, which could be, say, like some camera, microphone, light sensor, proximity sensor, um, and the ones like that. Okay, so many kind of sensors could be there. Then this comes to the very major slide for me, wherein we are talking about the survey of protocols and standards for the Internet of Things. This is from the article by Tara Salman and Raj Jain. Okay, so here you can see that there is something like a grid kind of arrangement. Why? Because you are having the stack. All right, the stack, which is a slightly different stack you're seeing here. That is on the left hand side. We have services at and on the top. Okay, so many types of services will be there, which is related to energy, entertainment, health, education, transportation. So many kinds of services will be there. But these services, depending upon the apps and the software which is there, so that the software dependent networks, service oriented architectures, collaboration, okay, the applications which have been developed, okay, cloud infrastructure which is there. So all these things are there. Okay, in fact, IoT has to be connected to the cloud because in IoT you have not imagined for the storage, whereas cloud is meant for storage and things like that. So IoT should be connected to the cloud infrastructure, and everywhere it is succeeding only because of those kind of connections. And then one more aspect is the analytics. So the analytics like machine learning, predictive analytics, data mining, etc. These are all the analytics. Because in the IoT we want to know, or in the protocols we want to know that what is going on, and applications would like to know what is going on and how do you change it, or so the predictive analytics and analytics can help us with that. And then you have the integration of the sensor data. So integration approaches are there. So which can do that. So GIS plus population, or GIS plus the earthquakes, etc. So many kinds of integration can be done. Then we have the one which is most basic level, which is the interconnection with some the various types of protocols, the Wi-Fi, Bluetooth, Zigbee, near field communication, NFC. Like that we have all those. Then how do you acquire the data that is coming through the sensors? So sensors, cameras, GPS meters, smartphones, etc. These all can be connected. And as you can see that on the right hand side, there are two things which are running constantly for all the layers or the applications, etc. which is there, which is the security layers and the management layers, which is running over all these kind of things. Okay, so you can say that it would be those are things which are built into the core part of the operating systems. And unless you can't have a good smart cities infrastructure unless there is a very good stable kind of a operating system kind of thing which is there. It's a maybe an operating system, but which is being taught in a somewhat distributed manner. Okay. Here is another view of how we are arranging the protocols. So what we see here is that there is an arrangement wherein the protocols, etc. So what we have is that you have the host layers, and then there are the media layers. Okay, so this is the following the standard 7-layered architecture from this Wikipedia kind of things. So you have various things, that is the layers which are there. So application layer is there, presentation layer is there, session layer is there, transport layer is there. Okay, data link layers, data layers are there for each of those. And then you have the segments, that is the TCP segments which are there. For each of the layers, say session layer, some data is there. So in host to host communication will be managed through the session layers. So then the presentation, that is whether the data is represented in what form, and whether or not there is some kind of a encryption. Okay, so that is at the presentation layers. And finally the application layers, wherein how the application is going to handle that. Okay, so all these things are part of the host layers. And then we also have what is called as the media layers. So in the media layers, it is a very basic thing will be the bits which are there. That is the physical media bits, the signal and binary transmission bits which are there. You have these frames which are there, and the data link and physical addressing, MAC and LLC layers are there, the packets and these kind of things which are there. Okay, so that is the standard 7-layer architecture, and these things, okay, I have to explain that because these are things and functionalities which are going to get mapped into the IoT aspects which is there on the left. Okay, so what you are seeing here is that what you are having the IoT protocols at various stages and at various levels. Okay, so at network layer level, what do we see? We have IEEE 802.15.4. Okay, so the WiMAX kind of things are also there. Ethernet is also there. Okay, then we have low power WAN communications are there. You are having the GSM and the LTE kind of network layer communications are there, and you are having the so many of the 802.11 series, that is B, G, N, A, C, A, D, H, A, X kind of protocols are there. Okay, now at the internet layer level, you are having the transportation, which is related to 6LoWPAN. 6 is IPv6. Okay, low is low power. Okay, so then we are having the RPL, which is there. Then it is the, and of course TCP kind of things are also there. Then at transport, you are having TCP, UDP, DTLS. Okay, so all these things are there. And at the application level, which we'll be seeing will be the COAP, MQTT, AMQP, and so many other things are there. Okay, so this machine-to-machine communications, which is there in IoT and all that, will be with respect to the use of the MQTT, and also this is a very good survey article which is there, from which I have got this. Okay, so now in another article, that is Edge Cloud Computing Technologies for Internet of Things, there is a different view which is there, which is that whether what is happening with respect to the data. Okay, so that basic aspect is that whether the data is at rest or whether the data is in motion. Okay, so if it is being communicated, the data is in motion. Right. So where is it that the data would be in motion? Is that where it is being moved across the physical devices and some controllers? Okay, there will be some connectivity. The edge and fog computing kind of things are there. Okay, and then if the data is at rest, means that it has reached some place where it is going to be processed. So the data accumulation, the data abstraction, and the application and the collaboration, etc., would be there. And all these things are, as you can see, if you notice that it is now 7 layers, which is there in the usual reference model, is now being applied onto the IoT. Okay, so this is what is there in the IoT reference model. Okay, so that is why it is being called as an IoT reference model. Okay, so this is the way it is there. Okay. Okay, so what are the types of communications which is there taking place is that you have device to device communications, you have device to server infrastructure communications, you have server infrastructure to the device, and that sharing of that kind of type of communications which are taking place. As you can see, in general we have what is called as a request response communication model. So this is the usual client server model. So in the client is that it wants something to be done. So then it will take and send a request to the server. The request will be received by the server, and it will be not serving not just one client, it may be serving so many other clients. Okay, so there are operating system processes which will be running simultaneously on the server. Multiple processes will be there because now multiple clients has to be served. Okay, so the clients connections will be taken and connected to some kind of process, and then the request which is there and the lookup or fetching of the resources will take place, and then it will be prepared into some kind of response, and that will be then communicated across to the client back. Okay. The server is the one which is going to manage the resources. So like, database connectivity, data connectivity, okay, all these kind of things, so that is going to be managed by the server. For example, say we have wireless network and you have some kind of a within the home kind of a network which is there, which is looking at some wirelessly connected light bulb, and you have a light switch. Okay, so as you know that through the wireless network, I'll be able to take the signal from the light switch to switch the bulb on or off, and it will be communicated to the light bulb, and that will be switching on and off. Okay, so here is some, say for example, some kind of an example. A slightly complex type of an example. So, but it is giving us the entire idea of these protocols and their connectivity and things like that. Okay, so at the bottom you have something like a board. Okay, so some Arduino web server kind of board is there, and that each thing there you have a IP address. Okay, and that IP address, and then you are having that there is a process which is working and configured, and it is going to be listening for the requests with some certain TCP port number. Okay, so this is the infrastructure which has been set up. That is, it's a web server which is running on some kind of a microprocessor, microcontroller kind of a board. Okay, and then it will be connecting to, say, maybe through a switch or a router or whatever, and then the packet forwarding will be enabled on that router, and any data which will reach some certain TCP port will be forwarded to another such set of default set of ports, so that this data communication will take place, and it can take place for on a transaction basis, or it can be set up on a longer term basis also. Okay, so that is all part of the internal network. Externally, what do we see is that what is being seen by the internet. So sometimes only one or two devices may be there on the internet. That is the gateways or things like that. Rest all will be part of an internal network. And the interfacing with the external internet is the one which is usually there with the ISP or internet and things like that. And the data which is being gathered by these end systems and all that, that will be configured and that can be communicated across the internet also. So this is giving some idea that how these things are arranged. So now I come to the application aspect. So we can look at some of the application level protocols which we are having. So as you can see here, some names of the protocols are given. Say MQTT. Okay, so that stands for a protocol for collecting device data and communicating it to the servers. Okay, so it is D2S standing for device to server. So that's the role of the MQTT protocol, that is going from device to the server. Then another one is the XMPP. So it's a protocol which is better for connecting the devices and the people, and it's a special case of the device to server pattern, but the people are being connected to the servers. Then you have this DDS, which is a fast bus for integrating the digital machines. So there people are not involved. It's a device to device kind of communication which is taking place. Then there is a AMQP, which is that it is a queuing system which is designed to connect the servers to each other. That is, it's a server to server kind of a protocol. Okay, so as you can see that depending upon the type of connectivity, the different types of protocols are required. Okay, this is another important abstraction to understand that how do we manage the communications? Okay, so what do we need to understand? What we need to understand is that the IoT devices are extremely low power devices. Okay, and unlike a server which is always on, the IoT devices may not be on at all. Okay, so the IoT devices would be looking to do something, and if some event or something takes place and they're measuring or something, and then they will take whatever they have, they'll communicate it and then become passive. Okay, so that is this kind of thing which is seen as that the sensors, etc., they are publishing their data. Okay, they have published their data and that data will reach a broker. Okay, so so suppose we talk about, say, that there are some sensors which are detecting whether a bus has reached any bus station or not. Okay, so you'll have something which is like that. So like this, the various publishers are there which are looking at data, and they'll be sending the data to a broker. Those who want to consume the data, they are the subscribers. Okay, so suppose somebody wants to travel and they can look at the bus schedules. Suppose somebody wants to travel by train, they can look at the train schedules. Okay, so like this, there are several subscribers. Okay, so the subscribers are waiting for the data to be published by the publishers, and they will but the subscriber does not know any specific publisher directly. Okay, that's the important thing to understand. No subscriber knows any publisher directly. It is managed by the broker, and the broker is the one which is having fair bit of processing power, energy, and all that, whereas publishers may be low processing power, low energy, and low computational resources, something like that. Okay, subscribers again may be rich or it may be poor in terms of energy and processing power. It all quite depends. So this is the publish subscribe model. So here what happens is that why do we need the broker? Why we need the broker? Because the broker would be always on, whereas the various sorry the various um, entities which are publishing, and they push their data to the broker. Okay, whereas the various people who are going to consume the information are the various subscribers. Okay, they may be asynchronous. Okay, so that is basically the important thing to understand, is that with this architecture of the publish subscribe model, we have made the subscribers to be asynchronous of the publishers. Okay, so that is a very important thing for this success. Okay, here again I'm putting that information, that is what is the benefits of the publish subscribe scheme. So basically it is a simple architecture which is having point-to-point links, and it can be replaced by and it's with a single connection to some particular message bus or broker. Okay, and it is relatively simple to add the device or delete the device, and the data which is published can be reused for the extending the existing services. Now, publishers and subscribers, as I mentioned, are decoupled in time. Okay, meaning they are running asynchronously, and also they don't need to know each other. Okay, they are decoupled in space also, because they need not be running at the same time. Okay, and they are now looking at the synchronization. They did not have a strong synchronization, because the operations and the tasks which are there would not be halted during the publishing and receiving the notifications. Okay, so that is the overall publish subscribe view. Now we can see that how this is being applied or used. So here we see that okay, let me just check on the time. Request that the organizers might tell me how am I doing with respect to the time and how much
Yes, sir.
time.
Yes,
Sorry.
time is there. Time is there, sir.
Okay.
Yes.
Fine. Okay. So the protocols which we are looking at is that there is this extensible messaging and presence protocol, which is also called as the XMPP protocol. This will be connecting through the text messages, and although it is having only text messages, still it is being run over the TCP. And okay, see, thing is that somebody may say that, oh, what's the use, for IoT or something like that? TCP is such a big bother. It takes so much time to set up the connection and all that. But the advantage of that is that TCP is a reliable service. Okay, so we can make sure that whatever message is there, we will be able to acknowledge that a message has been received, and we will be able to know that the message was sent. Okay, and if it was there any problems of this, then they'll be keeping track of the byte by byte kind of thing by the TCP, so that whatever is sort of missed will not be missed, and the entire message which was there will be communicated reliably. So that's a real big benefit of the TCP. Overheads and all that apart, still that is a very good thing. Okay. For example, an example which is shown here will be that if you can follow that link from the Uniba of Italy, or okay, where some XMPP server kind of thing is there. The example given is that of connecting the home thermostat to the web server. Okay, so now if you want to look at a smart cities perspective, so many homes may be connecting to some server, and then looking at the thermostat and things like that, the server is collecting all the data, and it may be processing that data to forecast that what would be the energy demand of so many homes with that level of the thermostat. No? So this is how example how these small things can be connected and used in a smart city. If you look at the XMPP protocol, in principle, you can see that we are having the XMPP client, which is having a client level communication, which is from client level to client level. Okay, but at the XMPP server, you are having the direct communication with the another XMPP server, and this way this public subscribe kind of approach is also being extended over here. Okay, so that is how the totally diverse kind of entities are connected, and they'll be able to do something. Now let's have a sort of a quick look at what is this AMQP protocol. So in the AMQP protocol, what we have is that this is a queuing protocol. Okay, so that is what is happening is that various messages are there which have to be delivered to the subscribers. Okay, and these again asynchronous and those kind of things are there, and then you have what is called as the AMQP broker. Okay, so various publishers are sending in their data into the exchange, and which is the AMQP QP broker, and the looking at the data and other attributes, the exchange knows that it has to set up, and it will set up a kind of a subscriber queue for that particular subscriber. Okay, so that is the way or the outline of how these things work. And the AMQP middleware will be targeting and networking all the data to make sure that the message is delivered as it is intended, or it will, whether some rebooting or something like that is there. One link I have given here if somebody wants to follow more deeper into that. Now at the MQTT level, so this was earlier developed by IBM as a lightweight and with the publish subscribe approach. And the big advantage is that it is highly scalable. Okay, so many publishers could be there, and several subscribers could be there. Okay, as long as this broker is there and they're having sufficient number of addressing and those kind of things would be there. So publisher, and you can see that each publisher's packet is made up of the MQTT message on top of TCP, which is on top of IP, like that, and that message is sent to the broker, and the broker finds out, and then it is seeing that which basically broker is maintaining some list that which subscriber is subscribing to what type of messages from which publisher. So then it just redirects those messages to that particular subscriber. Okay, so MQTT, where is it useful? It would be useful for healthcare, transportation, industrial control systems, for energy consumption. I think so. I already explained some idea of that. Monitoring city, controlling traffic. Okay, for smart homes, office environments also, and all these kind of things. Okay, so basically, because it is open and easy to accept, and it is easy to adopt, so that's why it has been a choice for the smart cities. And the MQTT is like your HTTP. Okay, the characters are easy for the publish and subscribe messages and things like that. So it is ideal for constrained networks such as the fragile low connection, low bandwidth and high latency kind of issues which we have with these IoT devices. Okay, and it can be made into a easy setup kind of thing with you can have delivery of the package, etc., but that's a separate matter. And it is designed for the remote objects with the limitations for memory, and also for limitations for power and things like that. So there is also a important thing, which is the quality of service. So there are three qualities of services with the MQTT, and this is described in the article, which is the link of which etc. is given here. So you have various quality of service with the MQTT. Okay, fire and forget mechanism would be there, and but this at the QoS 1 level, it is trying to see that it is received. Okay, because even without waiting, it is making duplicates and sending it across. Okay, until a acknowledgement is there that okay, such and such message is received. Okay. Now, if you want more reliability, that Q0S2 quality of service level 2 is there, where the sent message is sent, and there is a receipt or a token. Receipt token would be received, and it will be received only once, so it doesn't bother about the duplicates and things like that. So what is the advantage for using the MQTT? It's a lot of simplicity, as it was designed as an open protocol with the publish subscribe service. You had the message persistence with the specific quality of service. There is a message processing. There is a protocol will assume which device has the limited process, and some definitions of the data types, etc., which are all there. Now here we are showing the gamut of the MQTT applications. Okay, so all these things which is in blue on peripheral, they are the things which are done, and you can see how it could be various dedicated devices or software, and here is a generic kind of a thing wherein various applications are set up. Okay, so healthcare applications, industrial tracking applications, automated metering solutions, supply chain applications, alerts, location awareness. These are all important from a smart cities perspective. Okay, and all these things, like these days there is something about industry 4.0. So then pharmaceutical manufacturing, chemical, energy, and all these kind of things, they're all to be connected. Okay, so for that, MQTT is a universal connected one. Okay, Now there will be also a lot of challenges which are there in the IoT, because if you are having connections of so many types and things like that, so that is the kind of thing. But at a general level, we can say that the IoT applications are very good. You can apply them for very big data, kind of things. Their application is also good for security, privacy kind of things. Okay, so many other practical things can be achieved through the IoT. But there are certain cautions and things which I must convey. So, for example, security. The IoT is extremely vulnerable to the attacks. Okay, so because things are open, it is not meant to be very tightly defended against attacks. Okay, so that, but as it is connected to embedded systems and things like that, and it is connected to manufacturing and things like that, which is involving money and all that, so there is now a lot of security problems there. As the devices are having low capabilities, that is another problem. But as it's all a matter of cost, and one can spend more and make that better. Okay. There is so much of information now. Okay, as I had mentioned earlier, that IoT information one has to keep in the cloud. Okay, but that doesn't mean that there is no local copy of the information. So you may have information which is at a local level. All right, so edge level and those kind of things could be there. Okay, so that is also there. So privacy challenge is also there. No, because if I encrypt the name and other such data, so then only those metro people who are big clients, etc., would have that thing to decode. Right. So otherwise, that ordinary pure person will be stuck up. Okay, but important things to take care of when we are having this privacy issues is that where is that data going? Is it collecting a personal data? And at what time is it collecting the data? And how we have to take care of that? Okay, and so another important thing is that standardization. Okay, in any field, if you have IoT standardization, so IEEE comes up with the standardizations. So you need to keep looking for that now how the standardization will take place. Okay, so as MQTT was there, and with and IBM people were there, so that's how they came up with the MQTT and IBM coming up with this. Okay, then there is what is called as Zigbee Alliance. The number of companies, they are making products for Zigbee. Okay, so they are coming up with their own standards for low power, low cost wireless technologies. Okay, and other big players like Cisco and etc. have also contributed. Okay, then we have what is called as this scalability problem. Okay, so there are big problems due to the communication process. Very large number of devices are there, and so um, as the number of devices goes on increasing, so whichever protocol which we are having, will it be able to keep up with that? All right, so that has been an issue which is discussed in one of these research papers. Okay, so and so many questions are there. That is, what about the hardware which is there? What about which protocol is ideal for the addressing such things? And then what is the compatibility between the software and hardware? What is relevant for IoT and things like that? So many things are there. Now, a lot of research is taking place on TCP, because how do we reduce the timings which are there for connection setup, timings for the packet exchange? Okay, as you know, congestion control with TCP can play havoc on the low data rates which are there. Okay, how do you make use of data buffering and things like that? Okay, and there are so many connections which are there, connection setup, and how do we reduce this for the small amount of data? Now, the ridiculous case would be that you are hardly sending 1 or 2 bytes, but you are transmitting the setup through TCP, setting up such a big thing, and which is not worth the overheads and things which are there like that. Okay. So with that, I can maybe conclude and take some questions and things like that. So as IoT is one of the very great methodologies, and MQTT is one of the critical protocols. Okay, so this is the MQ service. There is message MQ services consisting of the publisher, server, a server, and subscribers is the key approach, and how the protocols are arranged. Okay, so many applications are there which can be discussed. Now, say this is one which is related to some Walmart kind of applications are there. So many devices are reading the products from the RFID sensors, and then they're collecting and pooling that information and sending it out. So it is maybe related to, so that so many members came and they they were put in, and so many applications could be it. Okay, this is a different mail ID. Don't worry about that. And I think maybe I should try to show some of the research papers also. As it's an FDP, always I believe in showing research papers, because for students kind of things we cannot show those research papers. It's a bit difficult for students to understand the research papers. Okay, so this is the one of the articles which I had mentioned, and as you can see here, so we can see this survey article. I mentioned this survey article, which is by Ray, and it deals with the IoT functional blocks, the utilities of IoT, supported technologies, hardware platforms, the communication standards. Okay, the communication standards is very important. So many of these things which I have mentioned, they are also mentioned here in this article. Okay.
Now your slides is not visible, sir.
Sorry,
sir. Slides is not visible.
Oh, okay. Okay. Because it is from a different application.
Okay, sir.
This WebEx is that window, etc., has to be controlled. Let me see what I can do for that. Okay. Maybe I will stop the share. Okay, I think now they should be visible.
Yes, sir. Now it is visible, sir, properly.
Yeah. I'm sorry for that. So this is the article. It has come in this journal, which is maybe not such a not such a famous journal like our IEEE journals, but the article I found was very readable. Okay, so that's why I am sharing this article. That abstract is there, and all these contents of this article you can see here: social computing, SIoT. So many, all the issues are also discussed here. Security issues are discussed, end-to-end security issues there. This lightweight security. So many things are discussed. So that's why I like this article, and maybe people can note this title of the article and its things, or else I can maybe send this article over to the organizers by email. Okay. So like this, we have these things. So perhaps maybe I can stop sharing and perhaps take some questions and have a discussion. Always that will be more interesting.
Thank you, sir. Dear participants, has there any question from your side?
Sometimes they will be putting the question into the chat message.
Yes, sir. I am checking regularly, sir.
I am sorry, I did not monitor the chat messages.
Sir. So, has there any question? Yes, sir, one candidate, one participant has written, please share your email ID. So I think your email ID is already there, sir.
Yes, it was there on the first slide.
There in the first slide. So you can collect, and if you have asked any queries, you can directly send a mail or directly to the sir.
Another thing is that if you just put my name Atul Negi into Google Scholar,
yes,
right? So then you will come across my publications, some of the publications which I have related to IoT field. You will be able to see those publications, and then from that you will be able to get some idea that what kind of things I have been working on, and then you may be able to see that how you can collaborate or take part with our activities.
So, sir, participants has written that it is no queries, but very good session, very informative session.
Thank you.
They are really happy, sir. And thank you so much, sir, for sharing a lot of information. This is Jalal Sarkar, sir. Jalal is speaking. Thank you, sir, for taking time from your busy schedule for sharing a lot of information about internet connected devices, human protocol layers and reference models, layered internet protocol stack, elements of wireless network, characteristics of selected wireless links, wireless network taxonomy of research in IoT ecosystem, overview of protocols, IoT reference model, and very important information about data in rest and motion. I think it is very important, sir, because data in rest and data in motion in very reputed journal, Digital Communication and Networks, and types of communications and publish and subscribe model, challenges in IoT. Sir, which will help us for preparing a good problem statement, I feel, sir, to carry out our research work. Thank you so much, sir, for your valuable time, sir. Thank you, sir.
Right. Thank you. Thank you
so much, sir.
Thank
you. Take care of your health, sir. It is very important for us.
Thank you. I'm doing okay now. Right?
Thank you.
Okay. Bye then. Bye.
Thank you.
Goodbye.
Thank you. So there is one information, one announcement for each participant that you need to be filled up your feedback form within predefined deadline. After that, your session will be closed. Okay. So please kindly fill up. Okay. And now there is a lunch session. We'll connect from 2:30 p.m. There is an industry expert. I hope all of you connect in the same meeting at the same link. Thank you so much.